what we are going to go through is that we are going to look at the last unit. This week will be the last week which we will actually have class. Okay, but don't thank me yet. It is going to look based on the physical database design, and that now covers the actual database design for all the classes which you might have discovered during class design, which is going to be database driven. Okay, so if we have a big class diagram and we're going to look at the entities and all of that, we're going to now look at how we're going to do that during the physical database design. Now, you'll see the presentation is there. I've opened it. It's physical data modeling. So we're going to look at quickly the purpose of physical database model and the relationships. And then to be able to apply the different steps to actually to transform a logical data model to a physical data model. And then to select the data types and nullability for attributes, and then using namespaces. So quickly, the purpose again for this is to translate the logical description of data into technical specifications for storing and retrieving the data. Okay, so ultimately it's about actually being able to retrieve your data and store your data in the appropriate matter of time, because it's also a matter of efficiency. So the goal is to create a design for storing the data that will provide adequate performance and ensures the data integrity, security, and recoverability of data, ultimately. So the steps involved in all of this is to go and identify your target database management system, then to structure your physical data model based on your logical data model. In some cases, just for engineering it. And then it's a matter of defining the actual data types, applying some naming convention and making it look proper. Then defining the nullability of columns or your attributes in that case. Okay. So you will see we are going to have to speak about our database management system. So in that case, we've mentioned two options, either DB2 as an option or SQL Server. Now both of them are relational database management systems. There is some components listed for the DB2 product, DB2 for Linux, Unix, and Windows, ZOS, the EISEN2A, all of it. But that is not that important. There's different versions which they actually have. Okay. Then there's also for SQL Server. Now this is developed by Microsoft. Who develops DB2? No, Linux is a variation of an operating system. No, Microsoft developed SQL Server. IBM develops DB2. Okay, so this is a different option that we have, and there is different products which they also have. Enterprise Standard Web Business Intelligence, Workgroup, Express. So that gives you quite a family of database products to work with. Now, in our case, we then need to, as the second step of this, is we need to go and look at creating a physical data model based on your logical data model. So that means that in some cases you might need to apply the principle of normalization, or even denormalization, where normalization is the process of decomposing tables in such a way that there is no anomalies, creating smaller, well-structured tables. So in essence, that means that we create tables which is just the appropriate size. So that means that we will have a product, but we won't place the order information in the product or the customer information in it. You would have relationships connecting them. Okay. Now, the goals of normalization is listed there to minimize data redundancy, avoiding the anomalies, to simplify the referential integrity constraints, making it easier to maintain data, and then better design representation of real-world future growth, because you can then scale it up better from there. Now, in some cases, as I mentioned, that we would also like to do denormalization. And so what we've done so far in the database design or design is to actually normalization, creating classes or entities which just covers that principle. For example, if we covered a person, we only looked at the person, or a class, or a subject. You only looked at the attributes which describe that concept. Now, in some cases, you might need to denormalize it for performance, so that you make your queries less complicated. Okay. So, denormalization is the process of transforming a normalized tables into unnormalized physical tables in order to optimize your data access. So there's different ways in which this can be done. For example, if you have two entities with a one-to-one relationship, that can be denormalized. Or if you have a many-to-many relationship with non-key attributes, that can also be denormalized. Sometimes we have a table that have a bit of a lookup. That's where we have reference data, and we can break it down. So for example, if we have two entities, we have a student and we have the application, and a student can place an application, but what are we seeing here from this? We can denormalize it by placing the application date and the qualification inside the student. So ultimately the student becomes a bit bigger. Initially, where if you had normalized it, you would have two tables. Now we're just going to have one table for the student. But the attribute information will be captured in there also. So if we had a many-to-many relationship with non-key attributes, in this case we have the vendor, there was some price quote information and items. What are we seeing? Ultimately 3 tables. They have denormalized it into 2 tables, the vendor and the item quote. So you'll see the description and this price is placed away inside the item quote. So it goes up there. Okay, so in that case they've denormalized it, and now we only need one query to actually get to the data. We don't need 2 joins. We only have one join between these 2 tables. In that case you would have had 2. So there's also, if we have a reference table, in that case they have storage instructions and items are one-to-many relationships. What they've done to denormalize it, they've placed this where to store and the container type inside the item. So whenever they create an item, they tell it where is this item stored, what is the conditions or information about that. Okay. Then as the third step, we need to look at selecting the actual data types. So the data type, is it going to be affected by the database management system? Earlier on we mentioned DB2 and SQL Server. By selecting either one of the 2, is it going to have an effect on the data types? Is the data types the same? Is the data types between programming languages like C++ and C# the same? The sizes differ, the conventions and how they are possibly used differ. Okay, so what we are going to be looking at is some of the data types which overlap and the information about that. Okay, so what you will see, there's a bit of information about DB2 data types. Now what they are just saying to us that a data type must be specified for each attribute which you are going to identify in your data model. So you must say what is going to be the data type for this. Now there's a bit of information about the DB2 data types. They have date time information which is captured by time or timestamp and date. Then there's character strings like in char, varchar, clob, blob, db clob. Then there's exact numeric types, small int, int, big int, decimal, dec, float. Then there's approximate numerics. Then there's also Boolean and cursor and XML, where there's a bit other ones for SQL Server. They also have date, time, then they have small date, time. In the latest versions, they've also now added date timestamp 2. And then there's now, for example, still char, varchar, text. There's also exact numeric data types like big int, small int, tiny int, decimal, numeric, money, bit. Okay, so that is just to give you an idea. Then we also have a data type conversion chart, which helps us to convert from one data type to another. Okay. In programming, you sometimes have to convert from one to another. Now, even in database terms, we have this, where we can go from varchar to char, for example. Okay. Now, what you need to note from this is that we can have an explicit conversion or an implicit conversion. We're in a place where the conversion is not really allowed. Okay. Explicit conversion is conversion where the database management system will do it automatically for you. For example, here's a case where we have char to binary or char to var binary. That it's going to do for you by itself. But implicit is cases where you must implicitly go and add sections in there. You'll see that it requires explicit cast to present, to move from one data type to another. So there's two options which we have. We can either cast data or convert to go from one to another. Now, how do we select the correct data types? Okay, so what you will see is when we look at this and we select the data types, we can either go from char, varchar, decimal, or numeric. Char and varchar will mostly be used for when we have character data. What is the difference between the two? Varchar allows us to have varying length. That means that sometimes we can say we'd like to store 50 characters, but now what happens if our data is only 20 characters? It's only going to use 20 characters of space. But if we use char of 50 characters, it is always going to store 50 characters. Okay. Then there's decimal and numeric, which gives us fixed precision and scale for numeric. We also have integer for the whole numbers, float, giving you a specific range to work with, then date, time, money, and timestamp. Now, what you just need to note is not all database management systems actually have the money data type. I know that SQL Server has a money currency data type. DB2 by itself does not have money. Is there money in this list? You see, we have an exact numeric data type for money in SQL Server. So sometimes we need to make decision about the database management system plays a role, but now also the way in which we're going to store specific data types plays a role. Now, as we mentioned, for the naming convention, we might need to look at specific components, how we're going to name the tables, the schemas, and the column names, and later on your views which might be created. Okay, so what is a schema? So you'll see a schema allows us to go and group tables into logically related units. So we can actually have a number of tables put together and say this is tables which is related to human resources or finances. Okay, so it helps us to organize a very complex data structure into smaller portions. So your schema name is used as a qualifier for the SQL objects from there on, and it can be separated by a period. So you can have schema name dot table name to go into that notation. Now normally we will have our schema name also as all capital letters when we go and define it. So the table name can either be qualified or unqualified. That designates the actual table name. A fully qualified table name is normally a three-part section, which is defined firstly by the location of the actual DBMS. Where is this located on, in which data store? Then the second part will then be your schema, and the third part would be the actual table name. So the two-part name can then either be to use the schema name dot the table name. So you only work with those two components. In this case, the table name must also be uppercase characters to make it easier to be used in the future. So your column names can either also be qualified or unqualified if you would like to explicitly identify a specific column. So in this case, we have employee.employee name. That is still an unqualified column name, but we can make it qualified by adding the rest of the information in there. We have the schema name and so on. Okay. Then there's quickly mentioned for views. Now, a view is really just a view which is created to show you particular types of attributes grouped together inside a view for you. Okay. Then there's a matter where they discuss the nullability of columns. What is null? No. Null can't really be replaced by zero because really zero is still almost like known. It is zero. Null normally denotes the absence of a value, that there is no value. When you fill out a piece of registration page and then there is these star fields on that document, what does it mean? You must write down the information for specific fields. What about the sections where you don't know, let's say, some of the fields? Are you now going to write something just because there's a space? Take, for example, these student registration pages. If you are a national student, are you going to write down a passport number? Okay. If you are a foreign student, are you going to write down an ID number? So that will be created based on the case. Now, what you will see now is going through is we need to make decisions about specific, is this, can we allow that a column can be null or not null? Okay, what does it mean to say not null? Okay, so not null means that it is required. You must enter data. Okay, so there is an example where they're going to go and create a staff member, and then they have a column there, ID small int, not null, primary key. And then they also have the name, varchar 9, department small int, not null. Which of those columns can we leave out? Can we leave out data? In this case, there's no mention that the staff member's name is required. Okay. It doesn't say to us not null. Okay. If we just had the characters null there, like for example, there, then it could have been that the name is optional. You can have a name entered, or you don't need to enter the name. Okay, but if we look at the ID number, there it says to us it's required. It is not null. It cannot be left out. Okay, you wanted to ask.
But if it's written like that, does it give us a tool that can make it null? Like leave it out?
Yes. In this case, it tells us null. So that means, oh, let's take out that. Even in that case, yeah, if the phrase null is not written there, it just means it is also going to mean null. What you will note that null is an optional phrase which you add in there.
Just don't put it in.
Yes. Or you put it in and you just write null there. Because later on, 6 weeks from now, you would like to know what did you write here? And why did you leave it out? Okay, why did they make it not null for the primary key?
It's an identifier
Okay, what does that mean?
of the stuff. So if you don't have a number, can say that person is on my stuff.
Okay, but can a primary key be null?
No.
Okay, one of the conditions on a primary key is that it must always contain a value. Okay, that's an identifier for the staff member. It is always going to contain a value. Okay, so then they just quickly have an example where they've indicated to us that we are migrating from the account to the account. You'll see the notational changes. In that case, it's now showing to us a table and columns. Each of the attributes at the bottom is going to become columns in my database. So if we look at this last one, what we also are seeing is that we actually have the column and we have the data type, which is associated. Okay. So what are we seeing from this is that the account number is going to be integer, account type is varchar, minimum balance integer. But they've also denoted to us nullable. What does nullable mean? Nullable is telling us that it's optional. If we look at the words we use, it's minimum balance reserved funds overdraft limit. Places like that is optional fields. Okay, but the account type, what does it mean if it's written like that? If nullable is not there, then it's not null. It is not optional. It is going to be required. Okay. So guys, this should be the last stage from here where we can then go and forward engineer a data model from here on. Okay. Any questions?